here is another determinant calculation, and this time a 4x4 calculation. These get really tedious really fast. So what we're going to look for when we start to get bigger matrices is tricks to make things go more quickly. So one of the nice things about that cofactor expansion is that we can choose any row or column to perform it on. So I see a particular row column, that very last column has a handful of zeros, so 2 zeros. So if I do my expansion on this, remember every term gets multiplied by the entries in this column. Those 2 zeros are going to wipe out a bunch of those big calculations. So this is going to be how I want to set this up. And so again, I'm going to start my little checkerboard of signs. So remember, we always start with a positive in the top left, and I'll make my way across to figure out what all of these signs are going to be. And that's going to tell me how I'm going to set all this up. So it's going to be -1. So I'm going to subtract a 3x3 determinant, and then I'm going to get plus a 0. And then again, minus 1 times another 3x3 determinant, and then again, plus a 0. And so yeah, I'll just fill in these 3x3 matrices. So this corresponds to that top right one, the first one. So I am going to eliminate the top row and the rightmost column. It should be kind of easy enough to see it's everything in the bottom left. And then this other matrix over here, maybe a little harder to see, but we're going to eliminate the last column and the third row. So the ones that correspond with the entry that I'm at, that third entry in the column. And so I'm left with 103, 226, and 4, 112. And notice I do have like those plus minuses up there, but they are only for determining the signs of the coefficients outside of these submatrices. I don't assign a plus and negative to the entries when I put them in these new matrices. They are just the entries as they originally were. So this is the first step of this cofactor expansion. And you see it didn't get us super far. We still have quite a bit of work to do, because now what we've got is 2 3x3 matrices to figure out. So again, when I determine these, I'm going to pick the easiest row or column that I can find. So in this first one, I like the second column. And over here, I've got a 0 in the first row. I'm going to stick with that because it's usually the natural choice. So just set up my checkerboard of signs, at least the ones that I need for the calculations. And yeah, so I'm going to go ahead. So make sure you be really careful with brackets here. So I've got the minus out front of the first one, and then a big bracket. And now I do my cofactor expansion for the 2 3x3s. So it's going to be -2, and then times the resulting 2x2 matrix, which is 2, 6, and 4, 12. And then I'm going to go down, so plus 0. And then minus the resulting one when I cross off that 1. It should be 2, 6, and -1 and -3. Yeah, and plus 0, I'm not going to write that again. And now I'm going to do the bracket for the other 3x3. So again, it'll be 1 times what's left when I get rid of the first column and first row, 2, 6, and 1, 12, minus 0, and then plus 3 times, get rid of the top row, rightmost column. So I'll have 2, 2, and 4, 1. I did just realize, caught myself on something that didn't look quite right. I believe I canceled out the wrong row here for this entry. So this, when I get rid of the top row, it should leave me with the -1 and -3. So I apologize for that. It ultimately didn't affect anything because both of those 2x2 matrices would have been non-invertible and therefore having a determinant of 0, but it was a mistake, so I should fix that. So let's go forward, and the 2x2s, now we have kind of a simple formula to break those down. So I'm going to have negative, what we can see is, so -12 plus 12 is 0. And then that'll be minus -6 plus 6 is 0. So all of that's just going to vanish for us, which is nice. And then I'm going to have, so this will be 24 minus 6 plus 3, and that'll be 2 minus 8. And so the left chunk here is just completely 0. I get a negative, and this is 18 plus 3 times -6. And we can see that this whole thing actually does just go to a determinant of 0. And if it's 0, we do know that it's not invertible.